Hello, hello. In this video, I'm going to work through the problems on the Chapter P review sheet. So let's go. Number 1, factor as completely as possible, and then we have several polynomials to factor. And the first one is a difference of two squares. Notice there's just two terms here. They're being subtracted, and both terms are perfect squares. They're both something to the second power. We have 2x being squared minus 9 being squared. So the two factors are 2x plus 9 times 2x minus 9. X squared minus 7x minus 30. There's no common factor here, but it is a trinomial that can be factored into two binomials. They both have to start with x times x to get x squared. They have to end with numbers that multiply to negative 30. And the outside and the inside have to combine to give you negative 7x. So we need numbers that multiply to negative 30 and add to negative 7, and they would be negative 10 and positive 3, so the correct factors are x minus 10 times x plus 3. Check by foiling, that does come out to give you x squared minus 7x minus 30. 7x squared minus 12x plus 5. There's no common factor here. There is a coefficient on the x squared. So the two factors don't both start with x. If we just had x times x, that would just be x squared. One of them has a 7. We would need a 7x times an x to get a 7x squared. Then the numbers that go on the end have to multiply to 5. So one's a 5 and one's a 1, or maybe one's a negative 5 and one's a negative 1. But then the outside, that would be 7x times whatever number we put here, plus the inside, whatever number we put here times just 1x, have to add up to negative 12x. So the way to get all of that to happen is to put a minus 5 on the inside and a minus 1 on the outside, so that when you FOIL it, you get 7x squared minus 7x minus 5x, so there's your minus 12x, plus 5. If you have another method or approach that you like to use for factoring this kind of thing, you're welcome to use it, as long as you get this result. And how about this one? 10y squared plus 40y minus 120. Now here there is a common factor. So the first thing I'm going to do is factor out the greatest common factor, which is 10. So after I pull that out, this is 10 times y squared plus 4y minus 12. And now I need to see if I can factor this. The two factors that this breaks up into would both start with y times y to get y squared. They would end with numbers that multiply to negative 12, and then those numbers would have to add up to positive 4. So how about y plus 6 times y minus 2? And then here we have a difference of two cubes. We have 1/3 power minus another. 27 is a perfect cube. It's 3 to the 3rd power. So we use the factoring formula that applies when we have one thing cubed minus another thing cubed. So there's going to be two factors. The first one is just going to be the first thing minus the second thing, t minus 3. And then the second factor starts with t squared. It ends with 3 squared. And it has these two things multiplied together in the middle. So t minus 3 times t squared plus 3t plus 9. If you want to check, you can multiply this back out and you would get t to the 3rd power plus some stuff that adds up to 0 minus 27. And then what if we had started with t cubed plus 27? So that would be a sum of two cubes, t cubed plus 3 cubed, and there is a formula for that that's almost the same as the formula we used over here for the difference of two cubes, except we have a plus in the first factor and a minus in front of the middle term in the second factor. So t plus 3 times t squared minus 3t plus 9. Number 2, here we're going to add, and we want to make sure our answer is in lowest terms. So when we are adding fractions, they need to have the same denominator, and these already do. So that's good. That makes things easy. We just keep x plus 4 as the denominator, and for the numerator, we take this 7x plus this 28. So we're done adding, but this is not in lowest terms. We can reduce or simplify this. So on top, we can factor out a common factor of 7. This would be 7 times x plus 4. And then that x plus 4 divided by the x plus 4 on the bottom simplifies to just 7 over 1, or just 7. 7 divided by 1 would just be 7. Now let's do a subtraction problem. Do these have the same denominator? No, they do not. That makes our job a little tougher. So the first thing we need to do, well, we need to get a common denominator, and to figure out how to do that, we're going to start by factoring the denominators that we have here. So x squared minus 10x plus 9 factors into x minus 9 times x minus 1, and x squared minus 12x plus 27 factors into x minus 3 times x minus 9. Now we want the denominators to be the same as each other. We want them to have all the same factors. They already both have an x minus 9. We don't need to do anything about that. But the first fraction is missing an x minus 3, and the second fraction is missing an x minus 1. So the way to make what's missing be there is to multiply the numerator and denominator both by that missing factor. So when we do that, here we get 4 times x minus 3 over all three of those factors, minus 3 times x minus 1 over those same three factors. Now the denominators are the same, so we can combine this, put it all over that common denominator, and the numerator is made up of 4 times x minus 3 minus 3 times x minus 1, and without the parentheses, distributing everything out, that would be 4x minus 12 minus 3x, and then a minus times a minus is plus 3. Now this numerator can be simplified when we combine like terms. 4x minus 3x is just x. The minus 12 plus 3 is minus 9. And there's an x minus 9 on top, and an x minus 9 is one of the factors on the bottom. So we can cancel or divide those out. And what's left on top? That would be a 1 over the x minus 1 times the x minus 3 on the bottom. Now we're going to divide. 20 minus 4x over x squared plus 2x minus 35 divided by 2x squared plus 7x plus 3 over x squared plus 10x plus 21. The way we handle division is by turning division into multiplication of the reciprocal of this second fraction. So leave the first expression the way it is, flip the second one over so that the numerator and denominator change places, and change the division into multiplication. Now that it's a multiplication problem, how do we handle this? We want to factor everything we can so that we can see what all the factors are, and if we have any of the same factors on top and on the bottom, we can go ahead and divide those out. So with 20 minus 4x, there's just two terms there, but they have a common factor. The greatest common factor would be 4. So pulling that out, we have 4 times 5 minus x. Down here, x squared plus 2x minus 35 factors into x minus 5 times x plus 7. Notice the minus 5 times the plus 7 gives you the minus 35 on the end, and the plus 7x on the outside combined with the minus 5x on the inside give you plus 2x in the middle. Then over here, the x squared plus 10x plus 21 factors into x plus 3 times x plus 7. And down here, the 2x squared plus 7x plus 3, one of the factors has to start with 2x, and the other one has to start with x. And for all the foiling to work out to this, we need 2x plus 1 times x plus 3. Now let's see what we can cancel. There are x plus 3's as part of the numerator and the denominator. We can cancel the x plus 7's. And I see a 5 minus x on top and an x minus 5 on the bottom. Can we cancel those? They're not exactly the same, but they are opposites of one another. One of those would just be negative 1 times the other one. So we can cancel them, but then we get an extra negative or factor of negative 1 left over. So when the dust clears and everything that we canceled is gone, here's what's left. Negative 4 over 2x plus 1. Number 5, we want to simplify this complex fraction that has 7 over x squared in the numerator and 3 minus 5 over x squared in the denominator. So this is easy if you know the trick and how to do it. The trick is to multiply the numerator of this big fraction and the denominator of this big fraction both by the common denominator of all the little fractions that appear anywhere in the big fraction. So this little fraction has a denominator of x squared. So does this one. That makes x squared the common denominator of those. So I'm going to multiply by x squared on top and on the bottom. Because when we do that, what do you get when you take x squared times 7 over x squared? The x squared over x squared cancels, and all that's left up here is a 7. Meanwhile, down here, we're multiplying through. We're using the distributive property. We're taking x squared times 3, so that's 3x squared, minus the x squared times the 5 over x squared. The x squared over x squared cancels out, and we just have 5. So here's what we end up with, 7 over 3x squared minus 5. Now a couple of multiple choice questions. The square root of x to the 7th power, so we got an x to the 7th under a radical sign, is equivalent to which of these? Is it x to the 1/7, x to the 2/7, x to the 7/2, or x to the negative 7? Well, let's see. X to the 1 over 7 power would be the same as the 7th root. But that's not what we have here. This isn't the 7th root, it's just a square root. X to the 2/7 power would be the 7th root of x squared. The denominator of the exponent tells you what kind of root we're taking, and the numerator tells you what power that's raised to. The kind of root we're taking is the square root, and then it's being raised to the 7th power. So the correct answer is C, x to the 7 over 2 power. Now, x to the negative 7 power would be the same as 1 over x to the 7th, which is not what we have here. And now what about over here? 16 to the 1/2 power is equal to which of these? Well, when you have something to the 1/2 power, that's the same as taking the square root of that thing. So the square root of 16, the number you have to square to get 16, is 4. So the correct answer is A. This is not 16 times the number 1/2. That's what 8 would be. But the 1/2 is an exponent. It's the power that 16 is to. 16 to the negative 1/2 power would be 1 over 16 to the 1/2, so that would be 1 over 4. And if this were 16 to the negative 2 power, that would be 1 over 16 squared, and that would be equivalent to 1 over 256. Okay, I'll do the rest of them in the next video.